Now that we know a relation is a function, how are we going to represent it? So we're going to introduce to you the function notation. So if I know that a certain relation is a function, we are going to call it y equal f of x. So y is a function of x. Okay, the f could be different. We have functions named g of x, r of x, t of x. So that does not really matter. Okay, so this is called a function notation. Let us see a few example, or before we do the example, let's look at the symbol itself so we can understand it more. So first of all, make sure you understand that this is not a product. So it's not f times x. Instead, it's f of x. So what's nice to know now that the y and the f of x stand for the exactly same thing. They are exactly the same. So if I say y or f of x equal to 3x minus 5, we know that x is the independent variable, and whatever variable we use here has to be used inside my function. Okay? So again, let us look at some examples. It says find f of negative 2 for each of the following functions. What is another way of restate this example? So this example is saying when x is negative 2, what is y? Because that's for f of negative 2. So when x is negative 2, what is y? So for the first example, we have this function. So if we want f of negative 2, we'll see that f of negative 2 is 3. Right there. It's what is y when x is negative 2. Let's look at it in a different format. How about when it's in a table? So when it's in a table, this is what we need. So what is f of negative 2? It's 11. How about in this format? What is f of negative 2? And you can see that the negative 2 is related to the 6. How about in this? What is f of negative 2? So it is all the way here. So when x is negative 2, what is y? Y is negative 1. So f of negative 2 is negative 1. What is y when x is negative 2? This is a very important example, and I left it open so we can do it together in this video. I will refer to it again later on. I'm going to put a star next to it to tell you that this is important concept, and even though it sounds easy, and it is easy, definitely, but when we're going to do more complicated things later on in 2.8 and in chapter 4, you'll see that it's not a big deal. So let's see, what am I talking about? Let f of x be 2x plus 1. So that's my function. So we need f of 2. I usually have so much fun with this in a classroom setting. So what is f of 2? That means what is x? So we are going to substitute, okay, the x with 2. And then we will evaluate 2 times 2 is 4 plus 1 is 5. That's the last time I'm going to do it like this. This is just to show you what it is. We will not find the final answer. I just want you to give me the substitution, then we'll worry about the value. So let's do it. Let's start. What is f of 1? It's 2 times 1 plus 1. What is f of 0? It's 2 times 0 plus 1. What is f of negative 2? It's 2 times negative 2 plus 1. What is f of t? It's 2 times t plus 1. What is f of a plus 1? It's 2 times a plus 1 plus 1. What is f of t squared? It's 2 times t squared plus 1. What is f of a star? It's 2 times the star plus 1. So I did it all in one so you can see the pattern. So f of whatever is equal to 2 times whatever plus 1. That's the idea of evaluating function. Now let us go back and actually evaluate. So 2 times 1, that's 2 plus 1 is 3. 2 times 0 is 0 plus 1 is 1. So these are the final answers. Okay, 2 times negative 2 is negative 4 plus 1. Negative 3. What is f of t? 2 times t plus 1. I can't do anything. That's it. It's just like 2x plus 1. It's 2t plus 1. What about this? This is 2a plus 2 plus 1, or 2a plus 3. What is f of t squared? 2 times t squared plus 1, and we cannot simplify anymore, and obviously we cannot simplify a star. Okay, so now let us do another example with more numbers and stuff. Here's a function. F of x is negative x squared minus 6x plus 4. Find f of negative 3. So order of operation, guys, is so important. This is negative. The x is negative 3 squared minus 6 times x, negative 3 plus 4. So let's now work it out. Now minus is outside, but negative 3 squared is a positive 9. Minus times a minus is a positive 18 plus 4. And what is that? 18 plus 4 is 22. Take away 9 is 17. Okay, I'm not sure. Oh, 18 minus 9 is 9 plus 4 is 13. B, what is f of 0? That's an easier one. So it's negative times 0 squared minus 6 times 0 plus 4. Anything times 0 is 0, so all we have is 4. But let's look at this one. F of x plus 2. So now we're going to substitute every place I see x with x plus 2. So don't forget the parentheses, guys. Okay. So I have the negative, which is outside. X, which is in this case is x plus 2 squared minus 6 times x, which is x plus 2 plus 4. Order of operation. So what am I going to do first? Am I going to distribute the negative inside? Absolutely not. And that is such a common mistake. I need to square the binomial first. I have a negative outside, and now squaring the binomial is x squared. I hope you still remember. Plus twice the product of these two, plus 4. Now we're going to distribute minus 6x minus 12 plus 4. Distribute the negative. Negative x squared, negative 4x, negative 4, negative 6x, negative 12 plus 4. Now let's add like terms. Well, first of all, I see the 4 and the negative 4. They cancel each other. I only have 1x squared. Now I have negative 4x and negative 6x. That's a negative 10x and negative 12. Here's another common mistake. That's the final answer. This is a function. We're not solving an equation. Don't bring out of nowhere equal to 0 and solve. So please don't do that mistake. Now, how do we find an expression for f of x from an equation? Well, simple. All you need to do is to solve for y and then change the y to f of x. So this one already solved for y. And then evaluate f of negative 1 and f of r. So what is f of negative 1? negative 1 squared, which is 1, minus 4 is negative 3. And what is f of r? Is r squared minus 4. For this one, it's not solved for y, so let's go ahead and solve for y. So let's add, let's subtract x from both sides first. So negative x plus 6. Then divide by negative 2 to get y is equal to negative divided by negative is positive 1/2 x. Positive divided by negative is negative 3. And now we can rewrite, instead of y, f of x is equal to 1/2 x minus 3, f of negative 1. So when x is negative 1, this is negative 1/2 negative 3. Common denominator is a 2, multiplying top and bottom, so that's negative 6, negative 1. Okay, so I am doing it a touch fast, but you can slow down and see how I got it. And f of r is simply 1/2 r minus 3. Okay. So now let us see the last thing in this section is increasing, decreasing, and constant functions. So the functions, let's look at that. We can describe a function by increasing, decreasing, or a constant. Simply, it says f is increases over some interval if whenever x1 is less than x2, remember x is increasing left to right. So when x is increasing, look at that, f of x1 is lesser of f of x2. So what do we mean by that? When x is increasing, y is increasing too. That's why it's an increasing function. But when x is increasing and y is going down, see, f of x2 is less than f of x1, so that is a decreasing function. And it is constant if it stays the same. This is easy looking at it graphically. So let's look at it graphically and do the final example. So to decide, the most important thing is to remember, guys, that you have to look at functions from left to right. So if you remember what we talked about, the scanner for domain and range. So this is exactly like the scanner for the domain. So let's do the following, left to right. Okay. Now, another thing you need to be careful with is that we are looking at the domain. So we cannot say from this point to this point, for example. There is no points, but it is, instead of saying it is, for example, increasing from here to here, we don't say from negative 1 to 1 comma 8. No, we're going to look at the x values and we're going to say it's from negative 2 to 1. So let us start increasing. Left to right. So here's what I do always. I'll ask the student, is this increasing? And look at the cheating, what I'm doing. I'm going what? Right to left. Right to left. So is it increasing? And some people will say, yes, it's going up. Left to right. So let's look left to right. Look at the graph. What is happening to it? It's increasing until we hit the negative 2. Then we'll see that the function is starting to go up, so it's increasing from negative 2, and it's an open interval, guys, to 1. Now, where is it decreasing? Well, we see an arrow. That means it goes all the way to negative infinity. And so it is going down from negative infinity to negative 2. Where is it constant? We see that it is constant from 1 to all the way to infinity. So from 1 to infinity. Let's look at B. Okay, so let's look at increasing and decreasing and constant. So let's look at first increasing. So again, the scanner goes left to right. So let me see. That's not increasing. Then okay, so we found it. It is from this X. Keep an eye on the X. Okay, so it's supposed to be the 4, and it is including the 4 to infinity. By the way, these functions we're gonna look at in 2.6. You'll understand these are called piecewise defined functions, so you will be familiar with how they look and why do they look so funny. Now, how about decreasing? Okay, so we noticed that when we went left to right, it was decreasing from negative infinity to this X, which is negative 3. So negative infinity to negative 3. What about negative 3? Is it included? No. So it's open. And where is it? Constant. Let's see. It is constant from negative 3, including negative 3, to 4, but not including 4. So it's closed at negative 3 to 4, but it's open at 4. Okay, this is extra. Let me ask you about the domain. What's the domain? Look at X values. What did I use? I used everything from negative infinity. Yes, I did use this. Yes, I did use every single point. Oh, I forgot to ask you the most important question. Is this a function? We're studying functions, and I forgot to ask, is this a function? The vertical line test, does that work? Well, it works in all of these places. What worries us are these points. So when X is negative 3, what is Y? Is Y both these values? Is it 3 and negative 3? And the answer is no. Again, we're going to study those in more details in 2.6. But yes, it is a function because there's only one value. This is a whole, meaning don't include this point, but include this. The same thing here. It's a function because at 4, it is not equal to 3, but at 4, it is equal to negative 6. So if I'm asking you what is f of negative 3, the answer should be 3. If I ask you what is f of 4, the answer is negative 6. Okay, so these are just extra, but I cannot resist. Let's do the range. The range is the scanner going down to up. So where do we start? At negative 6. We don't have any y's here. Do we include the negative 6? Absolutely, including negative 6. And where do we stop? Well, there's an arrow going all the way, so it is to infinity. Okay, let's look at this last example. And this last example, it includes everything in one place. So let's look at it. It says for the following function, this is f of x. Let us find f of negative 3. So what is the value of x when of y when x is negative 3, negative 1, negative 2, negative 3? So the value of y is 1, 2, 3. What is f of 2? So when x is 2, what is y? Negative 2. F of 5. When x is 5, what is y? 0. Now what's the domain? Scanner left to right, all real numbers. Negative infinity to infinity. What's the range? Let's see, down to up. We start at negative 2, and there's an arrow here, so it is including negative 2 to infinity. Where is it increasing? Scanner left to right. So it is increasing from x is 3 open on 3 to infinity. Decreasing, it is from negative 1, negative 2. It's from negative 3 to, the x is 0 here. Negative 3 to 0. Okay, let's talk about the common mistakes. The common mistake, again, people seeing it going to negative 2 and they think it goes to negative 2. Keep remembering that we are always looking at the x value. Everything uses x values except the range that uses the y value. Where is it constant? Well, it's constant from negative infinity to negative 3. And also it's constant from 0 to 3. Okay.